Here we go. The first thing that we're gonna talk about today is this idea of something that's called the change of base formula. Okay? And this comes in really handy when you're trying to evaluate logs with bases that are kind of unknown. So let me give you an example, right? So if we just want, log of, I don't know, I'll say 100, okay? This is very, very simple, right? What does this mean? If I don't write an actual base in here, what can you assume the base is? The base is 10. So this means that 10 to the what power would give me back 100, and of course x would have to be, this would be 2. This is not a big deal, right? But what would happen then if I change that base all of a sudden? And what happens if I want like log base 7 of 100? Well, what does that mean? Well, how do we do that, okay? Well, our calculator is, if you push, so let me show you. If you bring your calculators up right here and clear whatever's on your screen, all right? When you push the log button on your calculator, you'll notice that there is no base, right? The base is 10, okay? Notice that there's no 10 here. That's it. It's implied to be 10. So watch what happens in the calculator when you just punch in log of 100. We would expect the answer to be 2. And look, there it is, because the calculator is interpreting 10 to the what power will give you back 100. Okay, so then how do we evaluate logarithms where the base is not a 10? Okay? Yeah, so I'm going to teach you two ways. I'm going to teach you the change of base formula, and then I'm going to show you what your calculator can actually do, okay? So the change of base formula simply says this, that if you have a log with a base of a of b, so log base a of b, it can be expressed as the log base 10 of b divided by the log base 10 of a. So what students like to do to help them remember this is sometimes they'll just draw a line right there and say log b over log a, right? That makes a whole lot of sense. So if we want to figure out what this is going to be, log base 7 of what is 100, we can easily go to our calculator and use the change of base formula. So it would be log, where's my log button? Log 10, or is it 100? And then divided by log 7. And we get an answer of, 2.37 for all intents and purposes, okay? So this says 7 to what power is approximately 100? Well, we have figured out that 7 to the, what was it? 2.37, okay? So 7 to the 2.37 is approximately 100. That's what that means. 7 to the 2.37. So watch what happens when you actually check this on the calculator. If I do 7 to the, we said 2.37, right? I would get approximately 100, and look, there it is, 100.6 and some change, okay? Okay, this is really nice, but the cool thing about your calculator, and especially if you have this calculator here, is watch this. So I wanted to evaluate log base 7 of 100. So when I push the math button, all right, I have this underneath the math tab. If you start scrolling down, and you go all the way to option A, you'll see that it says log base, okay? So when you push that, check it out, it gives you the structure. So I could do log base 7 of 100, and of course I get the exact same answer as before. Now here's something even cooler than that. If you have this calculator here, if I push the math button, and then I push the alpha button, which is the button right above math, then you'll notice that the math button itself is the letter A, which is the one that we wanted. So when I push it again, it automatically puts it into my screen for me. The coolest trick ever. Ooh, word up. So go to, yeah, so we call that math alpha math. And then it comes right up for you on your calculator, which is a skill that you should have. So ladies and gentlemen, let's practice a little bit. If I give you log base 3 of 11, please evaluate log base 3 of 11 to 3 decimal places using the key feature of your calculator. Yeah. So watch it. I'm going to go math, alpha, math. Oh, sweet. There it is. Punch into 3. Punch in an 11. Push enter. And I'm getting 2.183. So what does 2.183 actually mean? Yeah, so 3 to the 2.183 is approximately 11, which you can check and see. Good question. You would say x is you wouldn't say x, you would say this. Log base 3 of 11 is approximately 2.183. You leave it like that. So basically what I have over here. Okay, box 2 is all about learning about the basic log properties that we're going to use today to condense and to expand logarithms. So the first one is called the product property. Alright, and so here's what it says. If you have log base A of two entities being multiplied together, so an expression of x times y, two things being multiplied together, it is allowed to be expanded over addition. So what I mean by that is that's log base A of x plus log base A of y. So what I'm saying here is that multiplication of logarithms can be expanded over addition. Okay, the second one, the really important, the next most important one for basic log properties is called the quotient property, right? The quotient property says this. If you have log base A of two entities being divided by each other, yeah, I mean, think about it, right? If multiplication and addition go together, well, then it must follow that subtraction and division go together. So this is log base A of x minus log base A of y. And this is our quotient property. So this is simply stating that the division of logarithms can be expanded over subtraction. All right, the third and final basic property here is called the power property, and here's what it says. All right, if you have log base A of x to the b. All right, so that b is an exponent. So log base A of x, and the whole thing is raised to the b. Well, the exponent is allowed to come in front and be a multiple of log base A to the x. So that's allowed to be b times log base A of x. You have b times that many, right? Which is exactly what it means to be exponential, right? You have that many. Okay, here we go. Let's do a bunch of examples here together where we're going to be simplifying the logarithm, okay? So let's do A. A is going to be this. What if I have log base 4 of 32 minus log base 4 of 2, okay? Well, first of all, what do you notice? You notice that there is a subtraction sign between these two logarithms, right? So if there's a subtraction sign between them, how can we simplify? Well, I'm going to choose to use which property? Yeah, the quotient property. It says that subtraction can be simplified by division, right? Okay, no big deal. Perfect. So then we're going to say this. All right. We can then say this is going to be equal to log base 4 of 32 divided by 2. So far, so good?
Wait, so those numbers have...
Okay, so this is equal to log base 4 of 32 over 2 is 16, right? Okay, no problem there. But log base 4 of 16, that's a number that we all know, right? Yeah, this is 2 because this says 4 to what power gives you back 16. So this is an answer of 2. So this thing simplifies down to 2. Okay, for part B here, for example B, I'll move over so we can see it a little bit. So for example B, there we go, the whole screen there. Ask yourself this question first, okay? Where did this 6 come from? It came from the exponent on the x. Where did this 5 come from? Well, it came from the exponent on the y, right? Okay, so let's go ahead and rewrite that in that form. So I'm going to choose to use picking this. So this is going to be log base 2 of x to the 6th plus log base 2 of y to the 5th. Everybody okay with that part? So far so good? Yeah. Yeah, and now I have an addition symbol, so I can combine this by saying this is log base 2 of x to the 6th times y to the 5th. And that's as far as I can take that one. Okay, you try with a partner. Log base 4 of 5x plus log base 4 of 3x. What can you do to that? Yes, this would be log base 4 of 5x times 3x, which of course would be log base 4 of 15x squared. So that would be the simplified version of condensing that logarithm down. So let's do some harder examples here. Let's do example A. What if I gave you something like this? 1/2, oops, sorry, no bracket there. 1/2 log x plus 3 log of the quantity x plus 1. All right. Yeah, no, there's no base here. It's base 10, right? Okay, first things first, where did this 1/2 come from? Came from the exponent on the x, right? Okay. Where did this 3 come from? Came from the exponent on the x plus 1, right? So when we begin, we're going to say, okay, this is log base 10 of x to the 1/2 plus log base 10 of x plus 1. Everybody get that part? Oh, to the third. Yes, thank you. Okay, now, what's a better way of writing x to the 1/2 power? No. Nope. No. The square root of x. Very good. So this is equal to log square root of x plus log x plus 1 to the third. I have a feeling that we forgot a few things here. So look here. The square root of x is the same thing as x to the 1/2 power. The cube root of x is the same thing as x to the 1/3 power. The 9th root of x is x to the 1/9 power. You guys remember that, right? No, you don't? Okay, now we do. Okay. Okay. So, getting back to our problem at hand here. So now I have an addition sign, right? So how can I condense through addition? I have multiplication. So it'd be log the square root of x times x plus 1 to the third. And that would be my final answer. Okay, a little more challenging here. 2 times log base 3 of x plus 2 minus log base 3 of x. All right? First things first, where did this 2 come from? Came from the exponent up here, right? And then I have a subtraction sign. So when I solve this out, I'm going to get, or when I condense this log, I'm going to get log base 3 of x plus 2 quantity squared minus log base 3 of x. So far, so good? Yeah? So far, so good? Okay. So, no, not square root, right? That's just squared. So now I have a subtraction, so I can condense over division. So log base 3 of x plus 2 quantity squared over x. And that would be my answer for that. Okay, so this one, notice that the 1/3 is sitting outside the entire expression, right? So that 1/3 is the exponent. By the way, the 1/3 is a cubed root, right? So that's going to be a cubed root of the entire expression. So I'm going to work from within the expression out, okay? So I'm going to keep that 1/3 there. Yeah, Rachel? No, because there's no equation here, right? It's not an equation, it's an expression. So we're working with the expression to simplify what we have. So I'm going to work inside the parentheses first. So I'm noticing that this can be log base 2 of x times x plus 1. You guys cool with that part? Okay, so I have this going on, right? Okay, no big deal here. Everyone's good? Okay, then where'd this 1/3 come from? Well, it came from the exponent in there. So this is log base 2 of, I could write this if I wanted to, as x squared plus x, if I wanted to, and then up to the 1/3. Have I done anything crazier out of the ordinary yet? You guys okay with this? Now we can rewrite 1/3 in radical form as log base 2 of the cube root of x squared plus x, and that would be an acceptable answer. This is called the monster. This is box 5. The reason it's called the monster is because I got a lot of stuff inside parentheses there, right? I have 2 minus signs, so that's like a division and then another division, right? So it's 2 divisions there. So what do you do? How do you work with this? Well, there's a lot going on here, right? So I'm going to work from the inside out, and I'm going to do a couple of tricks to make your life a little easier. So I'm going to keep my 2 here. I'm going to say 3 log base 5 of x minus, now watch this. I'm going to rewrite this as log base 5 of x plus 1 plus log base 5 of x minus 1. So all I did, you guys, and there should be another bracket here. Okay. Look, all I did was this. I rewrote this second half. I factored out the negative sign and made it that. That's all I did. It's a second expression there. And the reason that's good for us is because now I have an expression here minus an expression here. So now I went from 2 minus signs down to 1 minus sign. Do you see that? That's a huge advantage for us, okay? So I'm going to continue to work inside the minus signs, and I'll stay with orange. So I'm going to have 2. I'm going to have 3 log base 5 of x. Now I'm going to have minus. Now let's work inside here. This is going to be log base 5 of the quantity x plus 1 times the quantity x minus 1. Oh.
Wait, what do you mean you factored out a negative? Because wasn't that negative there?
Alright, so now I've simplified inside log base 5 of x plus 1 plus log base 5 of x minus 1. Anybody notice anything about this expression right here?
That's a foil thing.
It's the difference of 2 squares. Yeah. Okay, so 3 log base 5 of x minus, this has become log base 5 of, this is going to be x squared minus 1. Now if you don't see that, the algebra on this side, this is like a squared minus b squared is always a plus b times a minus b. That's what I have here. A plus b times a minus b. So that just becomes a squared minus b squared. Alright, we're in really good shape here now because now I only have one minus sign. Okay?
Divide.
Well, first of all, let's take care of that 3. That 3 came to the exponent right there. It's been bugging me, that 3 out in front, right? So that's going to be 2 times, I'm going to have log base 5 of x to the third minus log base 5 of x squared minus 1. Is everyone still alive? Everyone still with me? Okay. Now, working inside the parenthesis, I have a minus sign. So it's going to be 2 times log base 5 of, I'm going to do x to the third divided by x squared minus 1. Okay, because that's the quotient property. And then lastly, I can see that this 2 came from the exponent on the whole thing. I'll just cross out the 3 there. So I can rewrite that as log base 5 of x to the third over x squared minus 1 all quantity squared.
Well, doesn't he have like every single question on the test?
No. Okay? And look, there's the whole problem from start to finish. Okay, let's go the other way now. So we've just spent the whole time like condensing, right? What did we just do? Yeah, condensing. So we're going the other way now. We're going to expand it. My eyes get messed up. So now I have log base 10 of 4x over y. So this is going to be which property? This is going to be the quotient property. So I can expand this as log base 10 of 4x plus log base 10 of y.
Wouldn't it be minus?
No.
Oh wait, yeah, you're right. Excuse me. Yeah, minus. Division gets expanded through subtraction. Thank you. Okay, now there's one more thing that can be done, right? What do you guys see it?
You got the 4.
Yeah, you notice that this is being multiplied. So I'm going to have log base 10 of 4 plus log base 10 of x minus log base 10 of y. So that would be the expanded version of that up top. Okay, let's do log base 9 of x to the fourth over 729. Well, what do you notice right away? It's a quotient rule, right? So this is going to be log base 9 of x to the fourth minus log base 9 of 729. Everyone okay with that first step?
Yep.
Okay, no big deal.
Take the 4.
Yeah, exactly. Then we can take the 4 and we can plop it down right in front because that's the power rule. So moving along, we get this 4 times log base 9 of x minus log base 9 of 729. Well, I wonder if this is a nice number.
3.
Oh, you guys know, yeah. This says 9 to the third is equal to 729. So this whole number is just the number 3. You guys see it? So then I can rewrite this when I'm expanding down as 4 log base 9 of x minus 3, and that's as far as we can take it. Okay, box 7 here, more examples. Let's do log base 3 of 9x to the 5th. Okay, a classic mistake is that people want to move that 5 down in front of the whole thing in the first step. Why would that be wrong?
That's exactly the only thing I remember.
Because the 5 is only touching the x, it's not touching the 9. However, if it was written like this, then, Jake, that first move would have been correct. But do you see the difference?
Yeah.
That's okay. You're not the only one. So then that should be log base 3 of 9 plus log base 3 of x to the 5th. Oh, okay. Okay, this is making sense now. Yeah, well, ask yourself this question first. How much is log base 3 of 9? That's the number 2. Yes. So that's 2 plus 5 log base 3 of x. And that's all you can do with that one. Okay, look at this thing. Okay, log base 6 of the 5th through to 6. So this is going to be, looks like log base 6 of 6 to the 1/5 power. Very good. Okay. Because the 5th root of x, the 5th root of 6 is 6 to the 1/5.
So now you can say.
Yeah, and then now this 1/5 can go down in front because of the power rule. So I have 1/5 times log base 6 of 6. But as Rachel just pointed out, all of this stuff is a value of what? A value of 1. Because 6 to the 1st gives you back 6. That's the definition of a logarithm. So you're left with an answer of just 1/5 times 1, which of course is just 1/5. So all of that is 1/5. Okay, log base 8 of xyz to the 5th. Can you properly expand that? And be careful because that 5 is only on the exponent of the z, not everything itself. Okay, try it with a partner right now. Everybody get this is your answer?